In this video, I'm going to show you how to do a little bit of network analysis in Python using Atom. So the first thing you want to do after you open up Atom is create a new file. So I'm going to go to File and New File, and I'm going to save this. Just save it in my course folder as I'll just call it sna.py. Save. Now from here, the first thing we're going to do is import the modules that we took the time to install in the installation video. So those will include an import of NetworkX, an import of matplotlib, and an import of scipy. And what I'm going to do is abbreviate the names of these packages so that when I'm using them, I don't have to write out the entire name. So for NetworkX, I'm just going to write as NX after it. With matplotlib, the first thing I'm going to do is add .pyplot and then abbreviate this as PLT. And then I'll just leave the last import alone. Now the reason for each of these imports is this one's going to give us the tools to do the network analysis, and these last two are going to give us a way to draw the plots so that we can visualize them, and a way to work with kind of larger sets of data. So before we get started, just want to give you a little bit of the background and motivation for using a tool like this as opposed to a tool like Gephi. So Gephi is a great tool for visualizing smaller data sets. It's a great visualization tool and it can do a lot of different calculations. But I think that what you will find is if you start to try to import larger data sets and to do larger analyses, that it's just not going to work out for you. The visualizations will become very awkward and it just won't have the power to do the kind of analysis that you need on larger data sets. So that's where a tool like NetworkX in Python can come in and help us. So since in this chapter we're talking about random graphs, the first thing I want to show you is how to create our own random graph of a certain size. And so what we're going to do is start by saying G for our graph. We're just going to give it a name G and set that equal to, I'm going to invoke NetworkX, so I'll say NX dot, and I'm going to call upon the function that will generate an Erdős-Rényi graph. So that will look like this. So nx.erdős_Rényi_graph. And you'll notice, you'll see that it's changing colors as I go. That's because each one of these components serves a different purpose. So for example, NX, that's the name of the NetworkX package, and the blue indicates that I'm using a function. Now we can tell the Erdős-Rényi graph function how many nodes we want in our randomly generated graph, as well as, if you read the chapter, what the p-value should be. So remember, the p-value is the probability that if we choose a pair of nodes, that there will be a link between those nodes in the random graph. And so the higher we set our p-value, the more likely it is that we'll have a link between a pair of nodes in our graph. So we can generate a graph of almost any size. Let's generate a graph of 150 nodes. So I'll type in 150, comma, and then we're going to set our p-value. So let's set it at 0.2. So we'll have a 20% chance each time we have a pair of nodes that there is a connection there. Now what I'm going to do, remember, if you see the blue dot up here, that means that it hasn't been saved. So I'm going to go ahead and save it, and then I'm going to run it. So the first time I'll run it by going to Packages and Script, and then Run Script. It'll be the same if you're on a Mac, but after this I'm just going to use the shortcut. So for Windows, that's Control-Shift-B, and for Mac, I think it's Command-I. So I ran it, and you see that we don't get any output. That's because we've just generated this graph. We haven't printed anything out or anything like that. But what I can do if I want to give some feedback is type something like print, and in quotes say random graph created. So all I've done is just added a notification that I created a random graph. So if I run it again, you can see how long that process took. So a little over 1 second, and I was able to create a random graph. So I'm also going to print out a couple of other statistics, the first being the number of nodes. So what I'm going to do is write print, and then in quotes I'm going to say number of nodes, put a colon and a space, and then end the quote. And what I'm going to do is add a plus sign after the quotes are finished. I'm going to tell you what I'm going to write and then explain it. So the first thing I'm going to do is in parentheses write str, and then in another set of parentheses I'm going to write nx dot number underscore of underscore nodes, and then in parentheses I'm going to put our graph name, which is G. So take a look at it. You can see that I have print number of nodes, and that's like text inside of the quotation marks. And then I have the NetworkX call that's calculating the number of nodes in the graph. And all this str is doing right before it is it's converting the type of data that this is. So when this comes out, it's a number, but in order to print it out with this text, it has to be converted into that text type. So I just add str in front of it. But if you just follow this exactly, you'll be able to get the number of nodes. So let's go ahead and run that. And you can see that it printed out random graph created as well as number of nodes 150. Now I'd like to know what the average clustering coefficient and the average shortest path length are of this graph. So I'm going to write two similar statements, the first being print average clustering coefficient, add a colon, space, and end the quote. Do the plus sign with str, and then in parentheses I'm going to call nx dot average underscore clustering, and then in parentheses put G again. So you'll see it looks very similar to the statement before, except instead of number of nodes here, I have average clustering. So I'm going to run that, and this might take a little bit longer. Actually, it ran pretty fast. You can see that I have an average clustering coefficient of 0.207. And finally, let's check out what the average shortest path length is. So I'll again write another print statement. So print the average shortest path length and add a colon and a quote. Again, add that str so that I don't get any errors about data types. And then in parentheses, I'm going to write nx dot average shortest path length, and again put G inside the parentheses. So let's run this one more time. And you can see that I have now the number of nodes, the average clustering coefficient, and the average shortest path. So what this is telling me is that on average, it takes about 1.8 hops to get from one node to another node if I'm doing a shortest path. And that's a pretty low clustering coefficient. And that makes sense because random graphs tend to have low clustering and low shortest paths as well. Now let's take a look at what the graph looks like. So in order to do this, what I'm going to do is use a command of nx.draw. And I'm going to add some parameters here. So I want to draw the graph G. I would like a node size equal to 5. I want the widths of my lines, so line widths, to be equal to 40. And these are just choices. You can change these if you like. I'm going to choose a node color of, if you've ever used HTML hexadecimal for colors, this is what this is. I'll just be pound 28666E, and then choose an edge color. For edge color, I'll just use black, so that'll be pound 1, 2, 3, 4, 5, 6 zeros. And then after that, I'm going to say PLT, because that's the name here, dot save fig. So I'm actually going to save this as a PNG file. And what you'll have to do is specify where you want it to save it. So you'll have to specify the path. I'm going to just put mine on my C drive. So I can use C:/ and then give the graph a name. This should be an easy location for you to find. So I'll just call this randomgraph.png. Now let's run this again. And so I don't have permission to write to that folder. So what I'm gonna have to do, and I do want you to see this, it's kind of important. Let me take a minute to explain how to find an appropriate location to save a file. So on Windows, and you'd be in the Finder on Mac, but I'm just going to look for the folder that I want to store my picture in. So for example, I'm going to put this in my week 4 folder for this class. So what I'm going to do is right click the folder and go to Properties. And it's going to show me the full path, so the full location of this folder. So I'm going to copy that and then paste that in front of the file name here. And what I'm going to have to do is delete all of these slashes and flip them around in order for this to work. So I copied the file path, and now I'm going to flip all of these around and make sure that I have one before the file name. And now I'll save it and I'll run it again. And so it finished. Now what I'm going to do is go back to the folder that I was storing it in. Okay, so I added week 04, so it'll end up in that folder. I'm going to run it. And when it finishes, I'm going to go ahead and open up that folder, and you'll see that now I have that picture stored there. So I can actually see what it looks like. Now, if you want to adjust the random graph, the 2 parameters can be changed. So for example, if you want to create a graph that has 300 nodes, you can change that first number to 300. And if you want to increase or decrease P, you can do that by changing this number here. And P is going to be a value between 0 and 1. And the closer to 1 that number is, the more likely that it is you'll have a complete graph. The closer that number is to 0, like for example, if it's 0.01, the sparser the graph is going to be, the less likely that it's going to have a higher clustering coefficient. So you'll be playing around with these values in your assignment. The other thing that I'd like to show you is how to import data. And so what I'm going to do is move this block of code down. I'm going to do the following. So first I'm going to write path is equal to, and the path is going to be equal to wherever I've stored the file. So similar to how you have the file path here, I've stored this in a folder on my G drive. So it'll be G/CIDM6311/network/ and then my file is facebook1.txt. So if I take a look at my text file of Facebook data, what you'll see is a list of edges. So each row indicates one node and that it's connected to another node. And so this data format is going to help us process it using NetworkX. So from here, what I'm going to do is make a separate graph. I'm going to call this graph F. F will be equal to nx.read_edge_list of the path. So this will read in the Facebook graph. And after this, I'm just going to put a print statement that says print Facebook network data loaded. This will tell me when it's done. So from here, I'll run this. Now I do actually want to include this error. You can see at the bottom that it's telling me that the graph is not connected. This is actually referring to the random graph. What you'll notice is we increased the number of nodes and we decreased the p-value. So we made it less likely that there would be connections between pairs of nodes. And what this did is that it made it much less likely that we'd actually have a connected graph. We have to think that there is a critical point at which we have a connected graph. And clearly, if we have this p-value, that hasn't been achieved yet. So in order to avoid this error, I need to actually increase this p-value. So I'm going to increase it back to 0.2 and take the node number down back to 150 as well. And I'm going to try running it again. And it looks like everything loaded properly and ran properly. So what you're going to end up doing is processing the Facebook graph data that's been given to you the same way that you process this Erdish Renyi graph that you're going to be asked to create. And in doing so, you're going to make some comparisons between the two graphs. So what you'll end up doing is using these same functions here to print out information about the Facebook graph, as well as create another visualization for that graph. So what you'll have to do here is actually copy this, paste it, and then change the name of the image file so that you get a separate file. Now at this point, you should have enough information to complete your assignment. If you are finding yourself feeling completely overwhelmed because of whatever reason, if you haven't programmed before, or it's just a lot of new information, that's okay. Just give it some time. And then just let me know if you have any questions about any part of the process, and I'll see what I can do to help you. But at this point, you should have all of the different functions you need. For example, you may have to change this letter G to letter F if you're processing the Facebook graph instead. You'll have to do some copying and pasting. You'll have to play around with these two numbers in order to manipulate your random graph. You'll have to change the file path so that it makes sense for your computer, as well as make a copy of this and make sure that you create a second image as well. When you do that, so when you do, you'll make a copy, and I'll call this the Facebook graph. What you'll end up doing is changing the letter of the graph to F. And before you actually plot it, you're going to want to say plt dot close, and that will make sure that it actually saves a separate image file, not just the same file that gets written over twice. So again, please let me know if you have any questions, and I will see what I can do to help you.